Thank you everybody for coming. As you can maybe see, it is night time here in Europe, and it is a day later than it is there. So it's 29th of October on a Thursday. But I'm going to talk today about the state of Fury, which is, if you don't know, it is a build tool for Scala that I've been working on for a couple of years now. And it's turned out to be quite an ambitious project, as you will see, and I think has the potential to be quite disruptive in the ecosystem. So the way I'm going to give the talk will be to talk about where Fury is going, without really, mainly because I've talked about it many times before in other talks, without really explaining too much about Fury itself. But I would very much like to invite people to just speak up, turn your microphone on, and if you have a question at any point, I'll be happy to give more detail if I'm making too many assumptions. Just before I start, well, let me first say I work for, and I virtually am, Propensive. We're a one-person company, but I deliver training on Scala. So if anybody has any particular needs for particularly advanced level Scala training, have a chat with me at some point. I'm also an advisor to VirtusLab, who recently announced that they're going to be maintaining and supporting the working with EPFL, working on the Scala 3 compiler. So I'm very excited about that, and the prospects for having the same company work on the Scala 3 compiler and on metals and a lot of the tooling that is used in Scala, particularly for Scala 3, which is coming very soon. So, well, let me very quickly tell you where I'm planning to take Fury. There's a milestone coming before the end of the year. The first milestone will be what I call the first usable version, the first version I can recommend to people to try out and not be disappointed by certain features being missing. So Alecto, milestone 1, will come out before the end of the year, and that will be able to represent any build, more or less any build of any Scala project that is currently out there. You will see from the things I'm going to add in later milestones that certain features won't be added until later milestones. So after a few months, we'll have the second milestone, Megera, and Tisiphone. If you wonder why they have these interesting names, have a Google for Alecto, Megera, and Tisiphone, and you will find out why. And then my aim is within a year to have version 1 released and in use. So, what is Fury? So this is my very brief slide on Fury. It's a build tool for Scala. It is experimental. It's attempting to do a variety of different and new and, I think, innovative things with building. Key features are that it's command line driven in the same way that Git is. So you type commands on your shell. These will modify, mutate a build. You can run a command to run that build. And builds themselves are unlike builds for most other build tools. They are not a file that contains code. The builds are not run, they're not compiled, they're not executed. They are pure data. So this actually gives us a lot of advantages in how we can analyze and combine and compose builds, simply because they are data, and data is so much easier to work with than code. They also use sources rather than binaries as a primary form of dependency. You can use binaries, but sources are encouraged. And that gives us big advantages as well with resolving dependencies, particularly transitive dependencies between different projects. And whilst we may have to compile a lot of source code in order to get our first build, subsequent to that, it does work very fast. So I hadn't planned to demonstrate too much of Fury, but I will do a very, very quick demo so you can see the sort of operation of the tool. So here I am. This is actually an SSH terminal inside VS Code. Can everybody or can anybody see my terminal?
Yep, we can see it.
Yeah. So I can run a command like this. If I press tab on Fury, I'll get a list of possible commands. And one thing I might do is list the projects. This is actually the build for Fury itself. So this is a table. It shows there's only one project in Fury, that is Fury, which consists of 20 modules. So you might ask, what is a module? A module is a unit of compilation. And this is the list of the modules. If I scroll up, you can see the name of the module, the dependencies, where the sources come from that module, how many binaries, and you can get more detail on this with running extra commands, which compiler it uses, and they all use Scala, unsurprisingly. And there's some other information there as well. So having defined a build, and if for example I wanted to add a new module, I could add a new module with parameters and specify the type of module and details like this. This is how you interact primarily with Fury. And it gets exciting if I actually try to run Fury and build the project. This was actually very, very fast because it's already built. If I clean the compiler and then run that again, you will see what it looks like when it's building everything from scratch. So this is building the Fury project from literally nothing, from just a Scala compiler and standard library. It's finished building most of the dependencies now. You can see progress on the Fury modules. We get a progress report as it continues. If you look at the sort of lower left half of this graph, you can see the relationships between different modules. So you can see that there are links from Fury core, which is running at the moment, to Fury OGDL, IPFS HTTP client. These links here. So this is a representation of a graph of the dependencies. And then we finished compilation. It was successful. These are actually warnings rather than compile errors. And it gives us information about some warnings from actually the Java compilation. We have no warnings in the Scala code. So that is typical operation. You can run it in watch mode, where it waits for changes with a -w flag, and all of these operations run from the command line. So I talk about Fury a lot more, and I show a lot of the features in other talks. So I'm going to pause there. Maybe later on, there may be some things I raise in the slides that you want me to demonstrate. I might be able to do that. I might not, depending on how easy I think it is. But I will return to the slides now. And I will start to talk about what is in these milestones. So we're assuming a basis of a build tool, which you can define modules, you can define dependencies, you can define dependencies in external modules, and this is the current state of or recent state of Fury. That's been working for a while now. Fury has been bootstrapping for 18 months or so it was building itself. And one of the new things that is coming in the milestone in December will be support for publishing. Publishing builds as simple data files that allow you to reconstruct a build on your machine, having run it elsewhere. So these are not binaries. So Vivek asks, is there a facility to take an SPT project and convert it to a Fury project? The answer is no. And the reason is that the definition of an SPT build is based on code, and Fury sort of rejects the approach of using code to represent a build. Builds are data, which means that we can work with data structures in memory. We can very, very quickly compose builds. So one thing you can do is depend on a build for, let's say you have a project which depends on cats. There is a Fury build for cats. You can depend on that. That is nothing more complicated than combining two ADT instances, which all happens internally to Fury, of course, but all of the operations we do on that are kind of trivial data structure manipulation. And I will show you some of the benefits of that in the later slides. Now, you may think that it's very desirable to be able to take an SPT build, which someone's already written and then spent a long time working on, and to reuse all that effort. Actually, it turns out that specifying a build for a particular project is really very easy with Fury. It doesn't take weeks and weeks of development time. The builds are not the equivalent of 1,000 lines of SPT. It is typically, I did a demo maybe about a year ago now where I built Monocle, which I believe depends on cats. So Monocle is a lens library. And I was able to write the build in a talk in the space of about 2 minutes. So running a series of commands, I was able to create the build, depend on cats, specify the source directory. Can't remember what else I had to do. It wasn't very much. It's very simple. You specify the details, and something like Monocle can be created from scratch and published very quickly. And the same is true of most libraries, most projects that don't have complicated builds. Now, for something like cats, it takes a bit longer because it has a series of about six different modules that need to be built. Martin asks about, could I give a high-level feature comparison of SPT, Gradle, and Maven? Probably not without delaying the talk much longer. And also, I also don't know, I don't really know the differences between MIL and SPT so well, except that most of these, well, MIL uses code to represent the build, as does SPT. I think Gradle does as well. Maven is more data related, so it uses an XML structure, but it still involves editing a file. All of those listed, SPT, Gradle, Maven, and MIL. So Martin meant Fury versus these others. That's usually Fury is taking the contrarian view to what the others do. So it doesn't really use binaries. It uses sources primarily. One of the things that gives us is the ability to organize dependencies, particularly transitive dependencies, in a way that avoids sometimes very subtle version conflicts. So automatic evictions of binary versions doesn't happen. Everything is rebuilt. Jakob loves my use of contrarian. Yeah, I am contrarian in many ways. Bazel, I think, focuses mainly on repeatable builds. Fury aims for repeatable builds, but it is in a way up to the build developer to make sure they are repeatable. I heard a little alarm go off. Is that somebody putting their hand up? Or I don't know what the noise is. Anyway.
No, it's if someone joins.
Okay, right. Welcome, whoever that was. So I will continue with the slides, but keep asking the questions because it's a good opportunity for me to expand on some of these things in a talk that is more of a future of Fury talk rather than what Fury is. So it's an opportunity for me to talk about what features it currently has. So it is a matter of running a simple command to share a build. Sharing can be done anonymously, so you can share it. You get a URL that is a hash. You can give that URL to somebody else, and they can then access your build immediately. There's no process of publishing to Maven Central, waiting up to a day for Maven Central to process that, and then they can access it. It is immediate. It's as fast as committing to or pushing to Git. Builds are published with a major and minor version number. This is just a way for people to indicate the nature of the changes in a build. So when you publish a build, it can depend on external sources in a separate repository, but the changes you make may be considered significant or insignificant. If they are significant, so they change the version, you might want to update the major version. If they are just changing details like a description or maybe a subtle dependency that doesn't actually have any consequence, then that would be potentially just a minor version. And I'm also experimenting with the idea of publishing with an expiry date. Now, when we publish binaries, typically we publish for all eternity. We push binaries up to Maven Central, and we're sort of committing that binary is to be depended on for all time. And then we often regret it later. So the Fury approach, which is experimental, I'm not sure we'll keep it, but at the moment you publish specifying an expiry date, for example, 1 week. And if that week goes well, you can extend the expiry date for the same build. You can say republish for 10 years, because that's what you want to guarantee your users. That is what you want to indicate to your users is your confidence in that particular build. So you may have a long time, you may want to offer some sort of long time support for a particular version, in which case you publish for a decade. Subsequent versions, you may want to say, well, this is supported for 1 year, and set the expectations of your users appropriately, which also allows your users to be aware of all of their dependencies and all of the transitive dependencies and how long those builds have been published for. Now, the builds don't go away. They are just guaranteed to be valid or blessed, if you like, for the period of time specified. So it's very much about setting expectations, very much about giving the users of your library time to upgrade, to start questioning, to start getting the wheels in motion, to ask the right people to update their builds so that they know that they're always many months, hopefully, away from an expiration date. It's like I guess it's like a best before date on food. You're guaranteeing or promising rather that build will be valid for some period of time. It doesn't go away, but it's setting expectations. And publishing doesn't involve any complicated key setup. You can publish through GitHub with OAuth. So you just log in through a website and verify an application. So this is this slide is about a little bit about the structure of a build. Builds are defined in what I call layers, and a layer is equivalent to a build file, and it contains a collection of projects. Very often only one, but potentially many. And it can also contain imports, which pull in projects from other layers. So layers are defined in hierarchy. Layers depend on layers, and those layers depend on more layers. And these get combined Fury will import them and aggregate together all of the projects in all of the layers, and in theory will in that process of aggregation will deal with conflicts between projects. So if you have two different layers which depend on projects with different versions, or which depend on different versions of the same library, that is considered a conflict which needs to be resolved. And there are various ways that I'll tell you about later that can be done. But it draws your attention to that problem and gives you the tools to fix it. Now, this is normally this process normally happens in one big layer in the entire ecosystem, which is Maven Central, and it happens very incrementally, one release at a time. You maybe know that when you publish to Maven Central, you can only publish a library which depends on libraries which are themselves published, which means that if you depend on 10 other libraries, or maybe 50 transitively, they need to be published with the right version, or the version you want to use at least, before you can publish your library. And what this means is that everybody's waiting for everybody else a lot of the time to get things out there. So when a new release of Scala comes along, or a new release of CATS with breaking changes, everybody has to wait until all of their dependencies are published before they can publish. And this is really sclerotic for the ecosystem. This is what I want to fix. I want to make it possible for anybody to modify and experiment and work with builds. So by organizing layers are the build. By organizing them into a hierarchy and making them a simple data format and everything being based on sources, what you can do is you have access to the entire tree of builds if you depend on them. There's no concept of depending on the built version. You depend on the same version that the author of that library uses to build their project. You run that same build that the author uses. So you can modify it as easily as the author can build it, without having to fork a project, without having to publish locally multiple times. You have the same control over all of the layers, all of the dependencies that their authors do, which means you can experiment and change them just as easily. And you can publish them as well. You can share them. So this hierarchy gives us a lot of benefits for being able to easily change things. So Matthew says, I just noticed in the comments, Matthew says that build exploration is a great idea. Yeah, I'm hesitant to call it a great idea yet. I like to see proof of my own ideas before I call them great, but potentially it's a useful indication. So different feature. The slides will jump around between different features because there's a few different areas, but hopefully there will be one sort of general arc through Fury and where it's going. So Scala.js support. This is now possible very easily in Fury. For the first 2 years of Fury's life, it couldn't build Scala.js, so I made it possible to add a dependency on Scala.js. It's all built into the tool. You don't have to specify a plugin or anything complicated in the build. You just say depend on Scala.js, and you can export a JavaScript file much as you can export a jar file. Sources make it easier to work with Scala.js because you can rebuild everything without needing the JavaScript to be published. So you just build it yourself. And in theory, the same can be done for Scala Native. And I mentioned before, I'm working with Virtus Lab. They're actually giving me a full-time engineer to help me with Fury. I'll tell you what he's working on later, but it's very good to be working in the same organization that is now maintaining Scala Native as well. And just to take a brief diversion, Virtus Lab are supporting Scala Native work. I don't know if people have been following Scala Native, but it allows you to compile Scala to LLVM and hence to machine code. That is being upgraded. They've released Scala Native for Scala 2.12. Scala 2.13 is coming very soon, and Scala 3 support for Scala Native will come next year. And that is happening in the same company that's working with me on Fury. So all of these things being brought together under the same umbrella is really good for me. It's nice to know that there can be good cooperation between these projects. So universal updates, this is a feature that was added quite recently. And it is relevant in particular to potentially large hierarchies of layers where you bring in lots of projects and you want to change one, or there is a conflict. So I said that you can make changes to a layer, so a build, as easily as the author could. It's actually even better than that, because you may have many different layers at the same time which have some common, either a common, say they depend on an old version of something. You may want to upgrade that universally to all the layers transitively. This is potentially a big tree. And there are tools in Fury, commands you can run, which will do that. So if you have a dependency on a particular import of one layer, so let's say you import a layer which imports the Scala compiler. You want to upgrade from Scala 2.13.3 to 2.13.4. You can update that globally with a single command. Now that's maybe not so impressive, but you have dependencies also on different Git repositories. Let's say you have a dozen projects which depend on cats, and you just want to see what your build would be like. And when I say your build, I mean the entire ecosystem of dependencies that you have. See what that is like when it uses let's say a tweaked version of cats, a version of cats which is just a pull request. It's not been merged, it's not been published. You can globally, universally change the commit hash that you depend on, that any cats dependency depends on, to a different commit hash, and press rebuild, and it goes and rebuilds everything against that version of cats. This can also include definitions of the projects in terms of their module dependencies, and it will include binaries as well. So if you have a dependency on a particular binary and you want to upgrade or try to upgrade to a different version of that, you can globally change that to a different version. And it becomes completely feasible to recompile the entire ecosystem that you depend on, or even the entire ecosystem if you have a layer that provides, let's say the community build. That could be published as a layer, and you could try recompiling that with any kind of experiment you want. And what I hope this means is that we wouldn't have to wait literally months for updates to trickle through the ecosystem. We could do it right away as soon as someone opens a pull request. We can test it. We can test two pull requests against each other in different projects at the same time, very experimentally. So this becomes possible primarily because we're using data to represent builds. We're not using code, and Fury as a tool enables us to change these things. I'll talk briefly about binaries. If you've worked on a large Scala project with SBT, or I think even Maven, you'd get the same effect. and you have transitive dependencies, you'll often find that one of those dependencies ends up with two different versions concurrently on the class path. And what will happen is typically the older version will get evicted. And that eviction is kind of crossing your fingers and hoping that anything that depends on the older version, anything that was built against the older version, still works against the version that it was upgraded to. Now that is, I say fingers crossed, because there are no strong guarantees. The compiler has not checked that. There's no guarantee of semantic versioning being used. We really hope that everything works fine, and the worst case scenario is that we discover at runtime, the worst possible time to discover, we find out that an API has changed. We get a class not found error, or we get some sort of linkage error, and this is the worst case scenario. Fury will not allow that to happen because it identifies these conflicts up front and forces you to recompile everything if something changes, which means that the binaries that it uses, so it has to compile its own binaries, of course, but the binaries will always be compiled against the same version of the source that they started with. There is guaranteed consistency. There's no sort of separation of the binaries from the sources. There's no risk of any kind of linkage error. So this is fine for sources, but you can also depend on binaries, and often you have to if you're depending on a commercial library that doesn't have a source available, or if it's just easier to depend on a binary. And you have two projects which depend on different versions. We maintain an invariance that if you compile a project in isolation, so let's say you have a complex build. I'm going to use the cats example again. Let's say you compile cats. The definition of that build of cats, with all the tests that get run during the build, that must use the same dependency, same versions of all of its dependencies as would be used if cats is composed into another project, if you depend on cats. So what this is saying is, if you depend on cats, there is no possible, you're not permitted to silently evict a version of a dependency and hope that everything works. You have to have verified that that it is the same build with the same class path that is being run or compiled with and run when you build cats alone, as when you put cats and Doobie and something else and Circe into the same project and compile them together. So this is an invariant, by which I mean there is a warning, an error reported by Fury if this is not the case, and it gives you the tools to fix that. So this is encouraging compositionality. We don't really have compositionality if evictions can happen, because that can potentially cause breakages at runtime. So I'm just reading the question from Matthew.
No, it's actually not a question. I just kind of commented. It's pretty
you're summarizing. Okay,
yeah.
I will move on in that case. So one of the new features that I'm working on at the moment in Fury is workspaces, and this is more of a design choice than a feature. It's just my way of organizing the various things that a project can work on. So when you run a build, most of the time, all you'll be doing is compiling some sources and adding those to the class path of downstream projects. That is a typical role a library plays in a build. Some projects will not only compile their code, but they'll run it as well. So they'll run they'll basically run the main method of a Java application that you write, so it can do anything it likes. It can access the internet, it can generate sources, it can do a variety of different things. And if I allow that, and I want to allow that because I want to have the flexibility to do that, even if it's not the common case, but I want to allow people to do things like run custom operations during their build as Java. That can potentially operate on existing artifacts, and those artifacts are in what I call a workspace. And that workspace can access other things from upstream in the build, things that have been produced already. So you can depend on jar files that are generated from earlier steps, and you can then provide those in downstream. And without going into too much detail, workspaces are the means of managing this. I'm still on the Electo release, by the way, but this is the last slide, I think. And all of this is coming by December. Let's say you have two different layers, and they're different versions of the same layer. You want to know what has changed. Now, with an SBT build, you could do a diff of the code, and you could try and work out what that means. With Fury, we don't have to rely on understanding of the code or understanding what the diff of code is. We can actually do a comparison in the data structure, and because it's a general ADT that's used to represent a build, I can actually use I've got a type class which will diff any two ADTs. This is generated by generic derivation, which means that however I choose to represent the build internally in Fury, I can present to you, the user, a diff that tells you precisely what has changed between two layers. Now that's very useful for Git merges. It's useful for seeing what has changed between two different versions. And those differences will be presented to you in the form of a table of changes. So it might say that the module in project X, called module Y in project X, has changed its added a dependency. Or it might say that the compiler version has changed from 2.13.1 to 2.13.2. These will be just line items in a diff. And we have the option at the moment of doing manual merges. These are a bit, I say manual, it involves running more commands than I would like. This is something that will be done automatically later. So if you have two different forked versions of a layer, so you have a PR, for example, with a layer, and that PR has got out of sync because the main branch has moved on. You can look at the differences that have taken place in the main branch. You can look at the differences that have taken place in the PR, and Fury might be able to merge those automatically, or it might say that it can merge most of them apart from a conflict in a module which changed its name twice, once in each branch. And this is basically once again possible simply because the build is defined in terms of data and not in terms of code. I mean, obviously you can do code merges as well, but they're not guaranteed to be semantically consistent once the merge has taken place. You might need to do some tidying up. So that is that is the release that's coming before the end of the year.
I think we lost John. I'll try to ping him now over the journal channel here.
Uh-oh.
Yeah. Maybe his computer restarted or something. Nope, it's official. I guess this is what happens with remote conferences. So we should let's stick a little bit. I think he would maybe reconnect in a while.
Sorry about that. I'm not sure what happened, but yeah, I leave for 2 minutes, and it feels like I'm joining a different meetup. Hey Seth, good to see you. I didn't realize you were
there. Hey John.
So I think am I? Tell me if I'm not sharing, but I think you can see my screen again.
Yeah, we can see it.
Yeah. So I was talking about support for Bash and Fish, which are shells I don't use, but hopefully we can get similar kind of tab completions for those. I won't go into too much detail about that. People will still want to publish binaries. This is, I think, a fact of life, and Fury will provide support for that directly as a command from the command line. It requires capturing certain metadata that is relevant to the published artifacts. So Fury will give you the ability to specify that. I'm being called out on comparing Bash to Fish. Yeah, so there is I think there is a strict order that Fish is better than ZSH and ZSH is better than Bash. Just to clear that up in case anyone thought I was underselling Fish. So in early next year, I hope to have support for Docker modules. So remember, we're composing a build of modules which depend on other modules. The ones that we can do at the moment are generally compiling Scala code and producing a jar file, or at least appending something to the class path. There will be the possibility of doing the sort of things you can do with Docker as one component of the build. So that is that is something that's maybe quite exciting if there are things that you can't easily do in Java as a Java application. Maybe you need external tools. Maybe you need to use some native software. That would be possible by creating an image, specifying a Docker file, and then running it as a container. That is a sort of idea that came to me later. It was never intended to be part of Fury when I was planning it, but I realized that the model actually works quite well. Another challenge that people often encounter when they have dependencies on a large number of transitive dependencies is what happens if you have two libraries that depend on different versions of the same library, and you simply can't upgrade one to the newer version. That might be because you have sort of hard dependencies on details of those libraries. Now, as long as you don't need to have a single, as long as you don't have two libraries which depend on different versions of the same library that themselves share classes or instances of classes, as long as that is not the case, because in that case you really do have to solve some deeper problem, you have an option of shading one or both of those dependencies, which basically means rewriting the binary to move one package to a different package name, usually putting a prefix in front of it, so that you don't have a class path clash. So remember, what happens when you put everything onto the class path is it linearizes all of these dependencies from a tree to a flat list. And if you have two things with the same name, one of them takes precedence over the other, and the other one is completely invisible to software running that depends on that class path. That's problematic if you have that dependency. We will be able to shade binaries just by running a command that specifies the package that should be shaded, or maybe even automatically. This is experimental, but Fury knows what packages get generated by a particular module. It can then shade exactly those packages in downstream projects, which would allow two different versions of the same library with presumably different APIs to coexist on the same class path, but one would have a prefix to its package name. And this is, I consider this kind of a last resort. It's not really desirable to be shading binaries, but nevertheless, it is one way out of the hole of having a conflict somewhere in your dependency tree. That there is improved task management planned for the second milestone. Again, this is a bit of a non-feature. So yeah, Matthew mentions Jackson. Jackson is a problem I've had with different dependencies on different versions of Jackson, and it tends to be very widely used. And different versions of Jackson are widely used, and the issue is they use the same package, but one of them could be shaded. Back to improved task management. These items here, more reliable shutdown, what that tells you is that Fury sometimes doesn't shut down reliably at the moment. So that will be fixed. This is more of a bug fix than a feature. But I would actually like to give like a sort of task manager overview of what Fury is currently doing, because you can run builds in parallel. They are running on the same, they're at least managed by the same JVM. So there is it has to do quite comprehensive task management to work out what is running, what is waiting for sort of user interaction, which tasks are being deduplicated. So if you have two processes which launch the same build, exactly the same build, that will only be done once, and task manager could present that in a nice visual way, I hope. Now, this is a feature which exists in a different form in SBT, usually called cross-building. In Fury, it's called layer variations. These can be thought of as tweaks to a build. So builds will be able to have little variations that change some detail of it. Now, that might be changing from Scala 2.12 to Scala 2.13. Now, that tweak involves a few things typically. It will involve certainly specifying a different import of a different Scala layer. So you wouldn't depend on the Scala 2.12 layer, you would depend on the Scala 2.13 layer. So that is one little tweak. It's one little piece of data in the ADT that has changed. But it might also include additions to the class path. It might include additions to the sources. You may want to remove one source directory. You may want to add another one. And in many cases, you can have a collection of variations that could be combined. So you could, for example, have a variation which tweaks to Scala 2.13, one that tweaks to Scala 2.12. Now, those two are presumably incompatible. If you're changing the same data in each of those variations in different ways, that is a conflict. So those are variations which can't be combined. But you could additionally have a tweak which runs the tests as part of the build. And that is something which could be turned on or off in combination with changing the Scala version. You could compile optional dependencies. Now, the nature of a variation is that it can modify or tweak any particular detail of the build. Now, the build, I'll repeat myself again, is just data, which means that we can effectively change any aspect of that. We could be changing an import of another layer. We could be changing a module dependency. We could be changing the repository that's used and the commit hash or the git tag that it depends on. These are all tweaks in the data format, and they can be potentially combined in different ways as long as they're non-conflicting. And we can generate a compatibility matrix which would show which are viable, not necessarily, I don't want to say valid, because they still may not make sense in the same way that the cross-build versions of Scala native for Scala 230, which never used to exist. Cross-build was a sort of slightly sparse, wasn't a slightly sparse matrix. So the compatibility matrix would show you what could be combined. So I've been shown the 10-minute timer. Thanks, Matthew. I will go a little bit quicker through the last few slides because it's past 3 a.m. here, so it's getting late. Now, I've said at the beginning that Fury is based primarily on source-based builds, which gives the opportunity. I suppose I should start by saying it gives the possibility that builds could take a very long time if you have to build a huge tree of dependencies before you can build your own project. Now, that tree of dependencies is sort of roughly proportional. The compile time is going to be roughly proportional to the time to the size of your ultimate fat jar that you could distribute at the end of your build. That is assuming that more or less the total build size is proportional to the compile time, because there is deduplication of dependencies. It's not the sort of exponential problem where you have to build every dependency of every dependency transitively. There will be a lot of deduplication, but there is still the opportunity to speed that up by reusing compilations that have already succeeded, not necessarily run by you. And Fury builds are, in theory, and there is a flag to mark them as repeatable or non-repeatable, should I say, non-deterministic, if you don't want this to be done. But you can potentially cache those builds and make them available across a local area network or to some work group defined in some way. And I've been using IPFS. I don't want to go into too much detail about IPFS, but IPFS is a distributed, globally, in fact, they say universally distributed hash-based distribution network. It is a peer-to-peer network, which means that it's got two basic operations. If you give it some data of any size, it will give you back a hash that refers to that data that you can share. And furthermore, it will share your data in the process if you are on the network. If you give it a hash, it will give you the data, which it will find for you on this universal peer-to-peer network. What that means is that we can very easily publish builds when they are completed. And there is also a PubSub facility that works over IPFS, which means that we could publish binaries when they have, if we have just published a particular binary for a particular exact hash of a build. Remember, it has to be the exact version. It's not just version N, it is some long hash representing exactly that particular build specification. If somebody else needs that, they can they can listen to on the PubSub channel, and they will find out if that is available, so they don't need to build it themselves. So this is work in progress very much, but the tools available are there through IPFS, and this could make work group builds run much faster simply by sharing dependencies. So the final milestone, and the focus of this is more kind of external dependencies, and maybe the most exciting one, which I've been working on with VirtusLab recently, is to develop a new extension for VS Code. This is called Frosty. There's a new repository for Frosty, and I'm working with Tomek at VirtusLab on developing this. And the Frosty extension for VS Code, it's made really good progress in the first 2 weeks or so of development. Will give you access through VS Code, through various panels, to a tree-based visual representation of the layer. Not just the layer, but also the fully aggregated list of projects that you have access to, highlighting conflicts and giving you the ability to use your IDE, as long as your IDE is VS Code, to fix conflicts, view details of the build, navigate through layer, make modifications. And anybody who's been listening to the presentation so far and thinking that I'm talking about a command line interface and they don't really like command lines, or it sounds complicated to have to learn that, this I think will be the natural entry point for most users to start using Fury as a build tool. You will press a button in VS Code, or you will rather install the Frosty plugin. You'll press a button and it will generate an empty layer for you, and you'll be able to start working immediately. Frosty depends on metals, so you install Frosty and you've already got metals. You've already got Scala. This is actually effectively one-click install for Windows, Linux, and Mac OS, which I was struggling with to do from the command line, because there's so many differences between Windows, mainly Windows, but also Mac OS and Linux, that ensuring that Java is installed, ensuring that Scala is available, ensuring that you have a build tool that works is quite challenging. But through VS Code, if you've got the IDE installed, it should just be a matter of installing this extension, and you have a working Scala environment, not just with the compiler, but also with a build tool as well. We should also manage to have some really cool stuff like a 3D graphical representation of the build graph. So not just my ASCII art version, but a 3D navigable version with the mouse. This is something we experimented with. So it's hopefully going to be there for next summer's release. Layer merge is done visually, potentially even better integration with metals. So there's a lot of possibilities here, and this is something that is kind of ongoing in parallel with Fury itself, and it's probably what I'm most excited about as a. I'm seeing support for ASCII art in the chat, but 3D ASCII art, that's no. This will be a JavaScript web-based. Sort of embedded inside VS Code.
Yeah, cool.
I don't know if you've seen some of the work VirtusLab have done with. I think I can't remember if it's Context Buddy or Graph Buddy, but this tool that's built into VS Code and allows you to navigate relationships between different dependencies. We'll get the same sort of thing. Much less exciting is Fuse support. If anyone is familiar with Fuse on Linux, there's really nothing to stop us building a Fuse interface. So a sort of file system interface to accessing and modifying layers. If you want to work in that way, that might be interesting to some people. And then maybe the big thing for this release is distributed builds. Now, this differs a little bit from distributed caching, because what I was describing before was the ability to reuse successful builds that other people have done that are maybe necessary as part of your build. But if you have other machines on your network that are available and can build part of your complex graph for you, this is relevant if you have a very big build, as maybe some large corporations do, there's nothing really to stop us distributing those builds to other machines that are available that could do the work. It's a challenge to work out where to splice the graph and what to dispatch to other machines. But if we have distributed build caching available to us, that is already one half of the infrastructure we need. If our PubSub channel is already advertising builds when they become available and advertising a need for a particular build, then machines on the network can make themselves available to do work and can sort of have some sort of very quick negotiation to work on a distributed build. And as soon as that binary of the completed portion of the build is done, that can become available to the machine that actually needed it. So this is maybe you can think of this as preemptive distributed build caching, where the work can be split across multiple machines in anticipation that it will be needed as part of a build later. One other, I mean, it's basically the same thing, but one other possibility is that you could have an organization that invests in some super fast multi-core compile servers that are making themselves continuously available to do work and will compile faster than any one person's laptop. And I would wager that it's faster to send all of the data necessary over a local network, run that on a very fast server, and then make that available back over a local network to the user afterwards. I think that would be faster than trying to run the compilation locally, even with the cost of network transfer. That is maybe not really a COVID-friendly solution, because not many people are working from offices at the moment where they have fast gigabit connections between their machines. So this is less of a priority while we're all working remotely. But it's something
we do have our neighbor's Wi-Fi though.
I mean, if your neighbor is has their own computer that, I mean, maybe is no faster or slower than yours, but you can connect to their Wi-Fi and just dispatch work to them. There will be a sort of joining, a sort of process of joining a work group and leaving a work group that sort of it depends how much you want to share and care about other people. But generally doing less work, doing the same work once only is my goal. So if any network, any spare capacity you have available to you by whatever means, legitimate or otherwise, could potentially be used. And I think that is more or less the end of my slides, because I finished on this one by saying that I hope, it wouldn't be the first time I've pitched a date, but I hope Fury version 1 can be available by fall next year, which is what I call autumn, but to most of you it's fall. And the intention between milestone 3 and version 1 would be that I would I would add resilience, robustness, and 0 new features, and focus entirely on making sure that it is as reliable as it needs to be if people are to use it and adopt it. So that is my last slide. Thanks for staying as long as you did. For those of you who did, I don't know how many people.
I think it's a good time for questions now. Like if you have any good questions you want to talk on.
Anything I explained particularly badly over the course of the last hour or so.
I actually have
I think I have a question. Jacob here. Yeah. So you said that Fury is about data, not about code. So there is no like build file that defines the build.
There is no build file in the traditional sense. So you, in the same way as you modify data that is stored inside Git, you run commands that modify data stored inside Fury. And now the interaction with Git is a little bit, let me say a little bit interesting, because you want to sometimes commit a build to a Git repository, but you may also want to commit a build or make a build available externally to a repository. So I'm going off on a little bit of a tangent, but it's an interesting point to share with you, which is that bootstrapping a build tool is non-trivial. If you want to get adoption, it's more or less impossible to persuade every library author to stop using whatever they're using at the moment, which is probably SBT, and I don't think they should, certainly, but stop using it and start using your build tool, or even to persuade them to commit a build file into their repository. So I need a way, and I have a way, to distribute builds externally to the repository they are building. Now this has some interesting consequences, but it does mean that builds can evolve independently of source. So if the way a build changes, for example, you want to upgrade a minor version of a dependency, that doesn't change the repository. It depends on the same commit hash, but the build will be bumped up a version. So there's some interesting dynamics there, which I won't go into, at least partly because I don't know exactly how they'll work out, but I've spent a lot of time thinking about it. But it's certainly possible for a build to either be committed to a repository or to be completely external, managed separately, distributed by some other means. And the concept of a build file committed into a repository that looks like code or even looks like JSON is no longer it is not part of the design of Fury. It uses a format that is kind of opaque. You can look at it, you can see the content, you can read the line differences, but it's a fast format that's based on something called OGDL or Ogdal, and it means that well, it's not intended for human writing. The approach to modifying a build is to run commands from the command line or to use the plugin. Did that actually answer the question, or did that raise more questions that you hadn't even contemplated before, Jakob?
Yeah, I think it answers the question. I mean, it's yeah, I get it.
Yeah.
But now,
so
I think that this clarifies my next question, because you pretty much break all the rules about build tools right now. We have a we
Yeah.
don't have a build file. We are working with sources, not with binaries. We have distributed repository instead of centralized one, and you're even imagining distributed builds. So I'm wondering about how the community will switch from one version of builds to another.
Right. Do you mean how they would potentially adopt Fury, or do you mean how they would manage their own the evolution of builds as they change?
Yeah, like probably both, and on a different levels. How the open source communities will manage that, and how the closed source projects will manage that.
Yeah. So they're all good questions. I will probably just skim the surface of them. But adoption of Fury as a build tool, like I was saying just now, I don't see it as replacing SBT until, if ever, it becomes ubiquitous. Because it doesn't have all the features. I've got no hope, and I don't even intend to hope to persuade people that they should adopt it tomorrow until they've seen lots of proof that it is reliable, that they can expect it to be around in 5 or 10 years' time. Adoption is really challenging. So I see it to begin with as an additional tool that will help with things like managing ecosystems of complex dependencies that you couldn't do with a binary-based build tool. And also, I think I certainly find that it's a nicer user interface. That, I hope, will encourage a few people to adopt it. So I'd like to get early adopters who want to experiment, who are more willing to try something that is more bleeding edge. And my hope is that they would develop builds for other projects. So this is one of the reasons why it's essential that we can have builds that are available externally to the Git repository they're building, or the project they're building. So those could be defined and published and maintained by someone completely independently of the author. And my big advantage there is that they're very easy to write. So I cited the example of being able to build Monocle in just a couple of minutes. Now I experimented with how to do that first before I gave the presentation in front of like hundreds of people building Monocle, but it was about 10 minutes experimentation to get that working before I was confident to demo that in the space of about 2 minutes. And I think the difference between the difference I have to overcome, first of all, is that I know how to use Fury and nobody else does, or very few other people do. So there's an educational challenge to get past first. And once there are a few people able to write builds, I don't think it'll be too long before large parts of the Scala ecosystem are converted to have, maybe I shouldn't say converted, large parts of the Scala ecosystem have Fury builds available in addition to SBT builds. The other thing you mentioned was how would we manage the evolution of builds as they change. So people will be able to publish builds using a service which I'm calling Event. The idea is you vent your Fury. So it's Vent is the service that you will be able to publish to, and this is the one point of centralization, but it is a service that you could potentially have alternatives to, in the same way as you can have alternative artifactories. So the idea is that you would publish an event under your GitHub username, any project name you like, and this would be available. There would be an index that would be available to all users. And if I just do a very quick demo, this is running on. I'm in Frankfurt at the moment, and this is running on my computer.
I don't think we're seeing what you're sharing now, except the slides.
Yeah, I'm sharing the wrong thing. A second. And I've also lost my connection to the VPN, so I won't demo it, but I will instead make a bold claim that when you want to import a layer that somebody else has published, you run a command, you say Fury layer add, and you press tab, and it gives you a list of all of the organizational group names that have published layers, and additionally press tab again when you've typed in an organization. It'll tell you all of the layers that they have available, and that will very quickly download that layer, add it to your build, and you can then depend on the projects that are included in there. And that is published with a version that everything is hashed. So if you depend on a particular layer, you're actually depending on the hash, but it also knows what the layer name was. You can check for updates, so you can check if there's a more recent version. I mentioned at the very beginning that the idea of publishing under a minor version and a major version. The idea is that if it's a minor version, you can do an automatic update. Minor version updates should be safe. Major version updates of a layer dependency should require user confirmation and should be incremental. It's up to the user how safe they want to be. If they haven't checked for updates in the last year, and they want to try and update a dependency on something, they can run a command that does a recursive or transitive layer update that may find hundreds of changes that when you combine them all together don't work. But the idea is if you're keeping a build up to date regularly, then it's small incremental changes which you can do on a day-to-day basis.
Yeah, John, where people should start, kind of go to get started? Maybe just share some kind of useful first-time resources.
It's a good question, because so I didn't actually mention it in the slides, but my big dependency for milestone 1 is documentation. And if you have a look on github.com/propensive/Fury, that is the Git repository. And in the documentation or documentation directory is my work in progress documentation, which attempts to explain in a lot of detail how everything works. I don't know if that's really, I don't know if I'd really call that good getting started info, because that's the comprehensive guide. The getting started is still work in progress. And I have been delayed a little bit recently because I've been working on something else called ScalaZONE, which, fingers crossed, again, will be launching tomorrow. And after this call, although it's half past 3 in the morning, I'm going to carry on with a couple of details of ScalaZONE before I go to bed. And hopefully you will see on Twitter an announcement that ScalaZONE is live, and that will be lots and lots of course material on learning Scala 3, freely available, and the start of a bigger project.
So I think everyone should just follow you on Twitter. So it's the same handle as far, if I remember.
Yeah. It's at Propensive. Yeah, that's
yeah. So just like follow Propensive at Twitter, and then
yeah,
totally announce, we'll retweet and everything.
Yeah. By the way, Igor asked a question which is quite important about code review. How do you review changes to the build? So this is relevant in the case where your build is committed to committed to Git, and it changes, because those changes are no longer line-based changes that you can review inside on github.com. They are effectively some binary changes that have some semantic meaning. Now there's a couple of options here. One is that you check out the pull request locally and run Fury to identify the differences. So I mentioned you can do a diff between a layer. That is possible with between two different branches. Now, whether that is acceptable, I think that's to be seen. What I would like to do is have integration with with GitHub that allows you to view those changes, to view the differences inside GitHub. And I think that should be possible in some way. That there's GitHub has quite a vast API, and I would like to spend some time exploring what's possible. That might mean we have to run some GitHub actions which print the differences, which wouldn't be great. I think we can do better than that, but I haven't completely overlooked the code review side of things.
Yeah, I guess you would need to serialize somehow to more diffable mode. People can actually look at them.
Yeah, and then there's there's the builds that are distributed independently of Git, so the ones that you publish yourself. Now, I've you can imagine I said that you publish a build under a group name / project name, sort of mirroring your GitHub account name. I've enforced a rule that if you are publishing some changes to that, because there could be more than one person who is publishing. If you publish some changes, then you have to be publishing having already got the most recent version of the layer. So if you have version 6.7, you are allowed to publish 6.8, or you're allowed to publish 7.0. Those are the only two versions you can publish. So you can either go to a new major version, publish that, or you can bump the minor version. If you don't have that, then you're not necessarily up to date. Now, thankfully, publishing changes to a layer is, I think, not something that would happen very often. I think small changes to layers are unlikely. The same layer can carry on building multiple different commits of the same Git repository as that Git repository evolves without the builds changing. I speculate, I should probably say, more with less changes than are necessary to an SBT build on a sort of more less sort of gardening that you need to do on keeping the builds up to date. That is speculation. I don't know. There's a huge number of unknowns here.
Well, let's hope we'll figure it out. Yeah.
Yeah.
Okay, John, I would like to thank you for coming over and everyone who participated. It's just a really, really good seeing such an amazing progress. I personally, we're Scholarship totally will go and try some of the smaller projects to bootstrap with Fury. See if that works.
Wait till milestone 1.
Okay, sure.
Yeah.
You're just saving me some nerves, I see.
Sorry, say again.
Some trouble. I mean, you saved me some trouble. So I should wait a little bit more. Yeah.
Yeah. I realize that if you're releasing an open source project, you don't get an infinite number of opportunities to impress people.
Absolutely.
And
yeah.
Right now you will see things that aren't impressive. So I'm cautious that I can talk about all the exciting ideas, but if you try it and it doesn't work on like your combination of hardware, or I haven't provided a certain feature, it'll be a disappointment. And I would like you to have a good experience the first time you try, or at least be aware of the things that are missing. And that's a large part of the work that will go into that first milestone, making sure that it is sufficiently well documented, sets the expectations. But thanks for the opportunity to speak. I normally come to West Coast US once a year. This year, obviously, I haven't been able to. So it's good to at least have
always welcome. So and if everyone wants to give a talk, also totally shoot us an email, reach out, or any other topic, we're happy to host.
Yeah, thanks. So any more questions, I can answer them. I won't say offline, but elsewhere.
Okay, I guess. Bye, everyone.
Thanks, Matthew. Bye.
Yeah, thanks a lot. Bye-bye.